given by the NFDD and mayonnaise, that is Suvarna Madam C and Dr. Manas Kumar Sinha, NFDD Bhubaneswar. I would like to thank Dr. Savandas mayonnaise. And thanks for the giving consent to the Marsco to providing capacity building program to HIT NFDD. Today is an interesting topic. Actually, we have mentioned that is Freshwater Ornamental fish breeding. And the speaker is Dr. B.K. Mahapatra, Principal Scientist, ICAR-CIFE. And the second covered by Dr. Ravi Kumar, Director of Ravi Academy. And the topic is Stream Culture of Litopenaeus vannamei. So, I would like to share the registration details. Total registration details have been done 1146. According to the occupation, the students have joined 465 and 301 number of farmers have registered, 88 numbers of academic staff, 76 number of research scholars, 66 number of fishing industry, 44 number of government officials have registered the webinar. We have got the registration from 31 states of India, and out of India, 23 countries have registered. As you would like to conduct the webinar as a national webinar, but it is converting as international webinar because only for the speakers, we like to thank our speakers and the quality of the webinar. The people are accepting all over the world. So I would like to welcome our guest speaker, Dr. B.K. Mahapatra sir. Sir, good morning, sir. I would like to introduce Dr. Mahapatra sir.
Good morning. Good morning.
Sir. Good morning, sir. So I would like to introduce Dr. Mahapatra sir. Dr. B.K. Mahapatra sir recently working as principal scientist in Kolkata Center of ICAR Central Institute of Fisheries Education. He completed his postgraduate and PhD in geological science with fisheries specialization from University of Calcutta. Dr. Mahapatra recently trained on artificial tank fish culture from Israel. He has been engaged in fisheries research and extension activities related to the aquaculture and fisheries for more than 32 years. I would like to clap for you, sir. 32 years is more than huge. So here he has worked as senior scientist in fisheries at ICAR Research Complex, Shillong, as assistant director of fishery research at Department of Fisheries, Government of West Bengal, and as training officer in fisheries, Ramakrishna Ashram, ICAR. Dr. Mahapatra fellow of Geological Society, also fellow of Inland Fisheries Society of India, fellow of Geological Society of India, that is Fisheries Geological Survey India, fellow of Academy of Environmental Biology, and Doctor of Letters. He also received Ravi Memorial Award in 1970, Vanamy Memorial Medal in 1988, Dr. R.T. Doshi Award in 2005, Professor V.N. Pandey Medal in 2012, ICAR-CIFE Best Division Center Award in 2006, ICAR-CIFE Best Scientist Award in 2015, ICAR-CIFE Best Extension Scientist Award in 2016. ICAR-CIFE Best Institutional Award in 2017, and also he has Bharat Ratna Gold Medal Award in 2018, Bharatiya Uday Ratna Gold Medal Award in 2018, also India Award in 2018, and Glory of India Award in 2019. We'd like to clap for you, and we'd like to the personal sake, they would like clap for the sir. Thank you, sir, for giving that much of your experience to the fishery culture. He also created 25 Marsco. He has published and having the authors of 12 books in the country. Thank you very much, sir, for giving that much of good experience in your research to the fishery culture of the India. I would like to begin, sir, please, you will start your presentation. Thank you, sir.
Yeah. It is visible, no?
Yes, okay. If you can make it full screen, it will be nice.
Yeah.
Yes, sir, it's visible.
Okay. So, good morning, everybody, and thank you to the organizer who have invited me to deliver the lecture on freshwater ornamental fish. And I like to congratulate and also showing my regards to all the participants who present here in this webinar. So, now I am going to present the freshwater ornamental fish breeding. And very frankly speaking, I have started from my student life, and this ornamental fish I have started as my professional hobby, and then finally I'm trying to do some work, and whatever I'm just going to present, that is my own work only. So I am now presenting. So this is actually the history of ornamental fish culture, how it is begun. We should know before venturing into the topics that if we go through the literature, that 2500 BC, that the start of the Latin vivarium, and then 27 BC, the Roman Empire, the first fish who brought the indoor was the sea barbel. So if we see, then in 1853, that opening of the first public aquaria at the London Zoological Garden at Regent Park. And in our country in 1951, the India's old public aquarium, the Tarapurala Aquaria, was opened at the Maharashtra. And if we see from the ICR side, the government of India, Ganga Aquarium, it is established at the National Bureau of Fish Genetic Research. Hello.
Sir, give me a moment. Let me mute everyone. Just.
Yeah, it will take whatever time it is allotted. It is 1.5 hours or 1 hour. You tell, so accordingly I will finish.
Oh, okay. It's 1.5 hours, sir.
Yeah. So that point I will finish.
No. There is a lot of noise coming in. Let me just mute. That's what I said. Please give me a moment.
Okay. This is actually the first that 2500 BC, that how the vivarium it has started also, and these are actually the sea barbel when that Roman Empire, the first fish to brought in was the sea.
Patel. Thank you.
Lot of noise. Yeah. This is the one first public aquaria, the London Zoological Garden, and what I mentioned in the 1951, the India's first public aquaria in the Tarapul Aquarium at the Maharashtra. And this is the Baghi-i-Bahu Aquarium in 2007. That Baghi-i-Bahu. Lot of disturbance, yeah.
ऑर्नामेंटल फिश ब्रीडिंग वही तो है हाँ वही है ठीक है तो कर लो ठीक है
Please, please participants mute yourself.
Now I can start, I think, yeah.
Yes, please continue, sir.
And yeah. So now I'm coming to the what is the ornamental fish. That the varied form and fascinating beauty of some fish which has attracted the time immemorial and also named as the ornamental fish. These include both the classified and non-classified type of aquarium fish. And if we see that the classified one, that different kind of small fish and beautiful fish are there, even some under the non-classified fish, that food fish that are used in aquarium during their juvenile stage. And these are the different ornamental characters that by which that hobbyist people, they have liked the beautiful color, stripes and bending pattern, chameleonic habit, jumping behavior, charming predatory habit, so calm behavior, and also transparent body, small size, hardiness, sakar, killed endowment. So different actually ornamental characters are that are actually liked by the hobbies. That yeah. And now I'm coming to the diversified ornamental character of the ornamental fish, and accordingly different type of fish are there. And among the beautiful color, so we know that our Chana Barca, that is very actually price one. Even one fish at today's market price, it is more than 2 lakh. So this is actually the freshwater ornamental fish. It is available in the northeastern states. So likewise, that category that under the beautiful ornamental fish, different fish species are there. And another fish species, the low species, this is the Botia badmurai. It is from the northeastern state, especially from the Manipur. It is available. So here actually the different kind of transparent fish are available, and that is why that our Chanda Nama or Chanda Ranga or Chanda Bekuli there, that is actually treated as the Indian glass fish. And also the big size fish, Notoptera chitala, that due to their attractive appearance, also it had also treated as an ornamental one. And here actually the stripes and bending pattern, that is another ornamental character by which the Botia rostrata, Botia derio and Denio radio are important. And also the peaceful nature and calm behavior, among which that Stenops nobilis and Nandas are very much important. And also the ornamental criteria, that the jumping behavior, that is another criteria, and among which that Esumas dendricus and also the Chela lobuca and Salmostroma bachyla are very much popular. Chameleonic habit also another important criteria, and that is that Puntia selenius and also Bedis bedis and also Derio, that is also important one, and that is very much actually attracted by the hobbyist. And also that ornamental criteria, that that charming predatory habit, and that is also there, that among which the Chana gachua or Chana stratus and also Chana marulias and Glossogobias gaius are there. And also another actually criteria, that hardiness and longevity also, that also attracted the hobbies, that among which the Denio radio or the Chana stewarty also important. Sakarmoth also, that is another characters of the ornamental fish, and these fish especially they can cling on the glass wall, and that's why this fish also treated as a biological cleaning agent in the glass aquarium, and that's why that fish has a very good demand in the ornamental trade. Small size, I already mentioned, that is also important, that ornamental criteria, that among which that different the Derio, Bedis or Petia Gelia are different kind of the Erististis, Hara, and that is also important in the ornamental trade. And if we see that a total of 1,539 species of ornamental fishes are traded worldwide, where India offers more than 374 freshwater ornamental fish and near 700 that marine ornamental fish species. Besides, in ornamental fish sector, about 288 freshwater exotic fish and 300 marine fish exotic fish has been used. Now I'm coming to this is the distribution of the different ornamental fish. You see that northeast, it is one of the hotspot biodiversity of the ornamental fish, and likewise our western Ghat that also freshwater ornamental fish also plenty, and Lakshadweep the marine ornamental fish, and also West Bengal both the freshwater and marine ornamental fish it is available. Now I'm coming to the some of the freshwater ornamental fish. This is the barbs. You see the different barb group are present, and among which the Salini barb, the Puntias salinias, or Roji barb, the Puntias conconias, Sophor barb, Puntia sophor, and Tictobas, Puntia ticto, and also the olive barb, the Puntia sarana, and the Cylinder rasbora, Rasbora deniconias, and also the Kerala queen, we know the Puntias denisoni, that is also very much important among the barbs. And among the Denio in groups, and here actually the Denio dengula and Zebra Denio, the Denio rario, or giant Denio, that is Denio ecopinatus, and Naga Denio naganensis or flying barb Esomas delicus are important. And among the Bengal Denio, the Denio devario, it is important. And among the puffer fish, the Tetradon kutkutia, that is also important. And also that among the loach species, that Acanthocobetis botia, and also the Rani loach, the Botia derio, and orange loach, the Sistura sitimensis, greystone loach, the Bellitora brucei, and also the leaf fish, the Nandas, and also chameleonic fish, Bedis very much important among the gouramis. Am I not audible to you? Hello?
Sir, you are audible, sir.
Yeah, audible, yeah. So then under that snakehead also, that different kind of the Chana species are there, Chana orontomiculatus. You know, it is available plant in the northeastern state, especially in the upper part of the Assam and also in the Arunachal Pradesh. And this is also very much important. And giant snakehead, the Chana marulias, and also the Chana stewarti, and also I already mentioned about the Chana barca, and also the striped snakehead, Chana strata, and rainbow snakehead, the Chana blairi, and also the dwarf snakehead, Chana gachua. And also that among the glass fish, the three Chana species are there. Elongated glassfish, Indian glassfish, and Himalayan glassfish, and very much important. And we know that another, that Pengba, that Ostrobema belengeri, that is also important as the ornamental one. It is original habitat, it is from the Manipur. And the black shark, that Lebio kalbasu, and minuscule shark, the Lebio gonias, and also the Notopteras sitala, they are also among the featherback, it is important. We under that sucker mouth also that Pseudochenis sulcatus, and also the Gara gotaila, and among the eel species that Macrognathus pancalus, and Macrognathus aquilatus, and Macrognathus armatus, and also Genotodon cancilla, it is important. And also the catfish, you know, that white catfish, Rita, also the Himalayan Olaira longicordata, and also butterfly catfish, the hara, and blind catfish, Emlyceps orunachalensis, and devil catfish, chaka, and Asian stonefish, that hara jadoni, it is also important. And now I'm coming to the some of the exotic that lab bearer, and that is among which the platyfish, which has I already mentioned that are already entered in our country, and altogether 227 that lab bearing species it is available in Indian water, and also especially in the captive condition we can raise them and breed also. So Gypoporus maculatus, and Molly also the Poicelia latipina, and Guppy that Poicelia reticulata, and also the albino swordtail, black wagtail swordtail, red wagtail swordtail, and neon wagtail swordtail are important. Among that exotic, freshwater, that ornamental fish which are egg layer, that is the giant gourami. We know that Ospirema gourami, and also three-spot gourami, the Trichopodas trichopteras, and pearl gourami, the Trichopodas leary, and goldfish, the Carassius auratus, angelfish, the Pterophyllum sculeri, and also the discus fish, Symphyodon discus. It is also important. Actually, that among the red blood parrot, that is also another important fish, and Oscar, Astronostas oscillatus, and Albinosa, Pangasius suchi, golden arowana, the That is also important, and flower horn cichlid and also the koi carp, that important. So for breeding, actually, we should know how to identify the male from the female fish. That why sexing of the fish is very much important. And fish are either sexually dimorphism or the isomorphic. So sexes in the dimorphic species can be distinguished size, shape, and color, and fin pattern, and males are more colorful, larger, and with elaborate fin. And a remarkable sexual dimorphism is exhibited by the cichlid, barbs, tetra, and besides the live So that the sexual dimorphism, I'm coming that this is Acanthocobatis botia. It is one popular loach. It is available in the northeastern states. Here, male are more colorful than the female. So likewise here another, it is the glassfish, the chanda nama, the female having the ovipositor for adhering the sticky egg on the substratum. And also that male and that colisa, that is one is that upper one is male and below one is the female. That female it is dull color and male it is brighter in color. And female having also ovipositor by adhering the sticky egg on the substratum, by which we can easily separate from the male from a female piece. This is a dwarf gourami, the Colisa, the male and female. The male it is brighter in color, and likewise that female also it is dull color. And if we see to the Puntia sophor, that more brighter color in case of male and female, and especially that red blotch, it is brighter in color, present in the operculum, and here in the female, it is that it is dull in color. And both the sexes are generally bright silver with the black spot near the tail. So here actually that Puntia salinius, that male it is brighter color and female it is dull color, and always the male it is small and female it is the larger in size. And also that in case of Rasbora deniconius, which is popularly known as actually the pencil fish, the male are smaller in size and narrow body compared to the female. And in case of the Puntius gelias, the males are smaller in size and more colorful than the female. And in case of Dario or the red baddies, that males display the 7 prominent vertical bars in intermingled with the 8 silvery blue lines on side, and which continue that field. And always it is there brighter in color in case of male. And in case of baddies, that males larger than the female and display the bright color with 5 pairs of the black stripes and display blue pigmentation in the fins. In case of Botia dario, females are larger than the male, and sexually mature females are normally fuller bodied than the male. And in case of that magur, also that pointed, and especially in the catfish, if we see the male genital pupil is pointed in case of male and bottom sepate in case of female. And also that that big chocolate mohasir also has a very good demand in the ornamental market, and that Neolisocylus hexagonal fish, that the male easily we can separate the male and female. Female always it is the broader belly and also that larger in size, and in case of male it is that slim body, and when we exert the pressure on the belly, that milk will oozes out. Now I'm coming to the some of the how the live bearer we can separate that male in case of the short tail, and in case of male the gonopodium present, and also the tail it is sword like, and in case of molly it is also that gonopodium it is even present, and female you see that anal fin it is very ordinary look, and there is absent of the actually that gonopodium. And in case of tiger barb, you see the tiger barb that red nose mouth and a red line also in case of dorsal fin, and here it is the black line and the round belly. And female tiger barb are generally bigger in size, and male tiger barb are have a rounded belly and also dull color. And now I'm coming to the angelfish. That angelfish generally that in case of male, a large circular body and thick bumped forehead and thin pointed genital papillae. And in case of female, the small angular body and no bump on the forehead and blunt shallow genital papillae. And in case of that fighting fish, that beta splendens, that male are distinguished from the female by their longer following fins, and the male body is longer and more brilliantly colored. And in case of female, the beta should have a smaller white spot on their underside, which sometimes protrudes slightly. And in case of goldfish, that sign of male, that dorsal, the pectoral fin, the first ray of the pectoral fin, it is serrated. And the bent of the or anal opening of a female goldfish is rounder than the male. Now I am coming to the Coreodoras aeneas. This is another important that catfish. That is, males are smaller in length than the female, and female have a larger underbelly. When viewed from the top, will look a lot wider than the male. Now, domestication of the ornamental fish, and when here, especially for the indigenous ornamental fish we are collect from the nature, we need to domesticate them properly. And the fish are from the diverse ecological niche. Emphasis that's why has been given to the habitat requirement, food type, and water quality for the proper domestication. For captive maturity, dietary intervention plays an important role and trigger for the enhancing maturity. And here the domestication process, you see that actually according to the requirement, the different habitat are being provided. And here that we have raised also the leaf fish and also the baddies and also Aplucales branches. So these are the different habitat requirement. Also chana species, they require especially some hideout, and it may be sometimes weed, and also some around pipe also we have provided, and so that they can easily hide in the pipe. You observe here, so easily they are actually hide in that pipe. And also that some fish, especially the gourami, they require some weed. That's why weed also provided, and sometimes that habitat simulation for Botia Dario we have provided, so that easily they can live and also grow and also mature there for enhancing captured maturity also. So habitat stimulation, particularly how we have given the simulation, that is actually Pethia gelias, and as because they the slow moving river, and especially the sandy bed, and also some weed it is required, and that's why this kind of that habitat are being provided. And here also sometimes the setup for gonad development, and sometimes that simulating different photothermal regime, and also that here actually that some temperature we have adjusted, and also that environmental intervention for broodstock development and captive maturation that also made. And actually in our India, that indigenous ornamental fish bred in the captivity, different species are there. And here actually that different indigenous ornamental fish we have bred, and also package of practice have been developed, and also that variety, especially the shining variety, it has developed from the SIFA, that is on the Puntias conconias. And also now breeding technology of the ornamental fish, how it has developed and standardized, that this is the Denio radio. We know that here they require only very minimum management requirement during breeding. During breeding, actually, that at least prior to the breeding, at least 1 or 2 weeks, we need to separate the mature, that brood and female, with some separator. And also we can keep in the same aquarium, no problem. Only thing we need to separate the male and female by arranging the separator, one side male and another side female. And we need to provide some of the actually that some stone chips, so that easily that when they lay egg, it can hide in that under that only hideout only. And after 10 days, only when you just remove the separator only, they the male and female mix together and they will breed. Here actually generally we do not require any put the hormone injection. So this is actually the zebrafish breeding, and also the Puntia sophor, that another actually the small indigenous fish, and has a very good demand in the ornamental market as a sophor barb. Here you see that here already I have mentioned that male, it is brighter in color, especially the red blotch, prominent red blotch present in the opercle of the male, and also female actually here that red blotch are not prominent. and their egg are little sticky in nature. Either we need to provide the weed and also or we can provide some of the actually nylon thread as a breeding mop so that they easily breed and attach their sticky egg. Here actually the breeding egg, and also here you see here that fertilized egg and also the developing embryo, and this is the hatchling, and hatchling generally they do not take any food, and only after yolk sac when it is observed after 2 to 3 days, then only they will start eating. Yeah, and at that time generally we supply to the actually some kind of that plankton, so different actually food we have provided, and also here that Raspora also I could able to successfully breed them. It is popularly known as the pencil fish. Here actually male are cylinder, already I mentioned, and female it has some actually larger size, and they also easily we can breed them through separation technique only, and before actually yeah, allow them for breeding, we need to separate them at least for 7 to 10 days. And when we just release together, they will breed there. And that egg also that hatch after 18 to 20 hours. And then also it will take start egg, yeah, the taking some food only, that fast food after 2 to 3 days only. These are actually the different actually that breeding technique, the details that egg depositor I already mentioned. It is egg depositor, and small aquaria. It is important for doing the breeding, and before spawning they select site the lay egg. They generally lay egg 100 to 250 eggs, and all that hatching will occur, and only the free swimming stage they will take some food. And also breeding and larval rearing in the Gorami. Here Gorami actually the bubble nest builder. The male generally they prepare the bubble nest through their bubble only. And here actually while this is in cement system, how I arrange them. Actually here you see here we have provided some actually thermocol that actually that piece, and here actually they attach actually their bubble nest, and here they will lay egg, and the male always it is male brighter in color, and female it is a dull color. And this is actually that May to August, it is their breeding season, and generally that glass aquarium 30 into 15 into 20, it is suitable actually for their breeding, and dried banana leaf or thermocol piece, what I mentioned, that is we need to provide them, and female lay egg about 1,000 to 1,200 egg per spawn, and hatching and larval rearing that here.
Excuse me, sir.
Yes.
People are complaining of your voice is not very clear. Can you hold your mic a bit closer so that it will be audible to us? Thank you, sir.
Yeah. Hatching and larval rearing, the eggs hatch in about 24 to 26 hours after fertilization, and also our Anabas testudineus, that is a parch, they are also important as a indigenous ornamental fish. And here actually that they lay egg when we inject them at the rate of 0.2 ml per kg body weight of the male, and also 0.4 ml per kg body weight of the female, and they will lay egg, and egg are generally floating, and they will hatch after 18 to 24 hours, and then they start taking actually their fast food after actually 2 to 3 days, and initially we can supply them as a egg yolk also they are eating, and also small actually infosorians they can also eat, and they can also very small actually enclosure we can also breed them and also rear the juveniles. And another actually I have tried and also successfully bred, that is actually the chocolate mohasir. And here actually the right male, it is that when we exert the pressure on the belly, then milk will oozes out. And also in case of female, that right female, if we pressure on the belly, then egg will come out, and through their artificial stripping and fertilization, we can easily breed the chocolate mohasir, and also they hatch them and successfully. And they are actually breeding season actually May onwards, and during July to September they breed very peak season. And the sex ratio observed, it is one female is to 1.26 male. That is always male. It is always larger quantity. It is required. This is the breeding and larval rearing of the albino cat. That is our albino magur, and that also we can breed them. And here actually we need to put the injection, and that is actually for female it is required 2 ml per kg body weight, and male it is required 0.5 ml to breed them. And we need to artificially fecundation need to fertilize the egg, and then also we can also hatch them. And they are also starter feed. We can use even that small plankton. Chocolate mohasir, that is Neolisocylus hexagonalipis. Chocolate mohasir. This is the albino magur. This is the dose what we need to inject them, and in the base of the pectoral spine, or in the intermuscular injection we can also provide, or interperitoneal injection also provide. Stripping and fertilization, it is required. Already I have mentioned that egg were successful here in two different way. Even sometimes we need to hatch in the hatchery also. In the larval rearing stage, usually stocked in the rearing tank at the rate of 1,000 number per liter of water, by maintaining the constant flow of water and the specified water depth of the 6 centimeter. The yolk sac absorption is usually completed within 4 days, and no food is applied during hatchling. Only in the when they got spawn, that time only we need to feed them. This is another ornamental fish. This is actually that our Pterophyllum scalari, which is popularly known as angelfish, and they also that the egg depositor only. That sticky egg they need to deposit, and that's why it is when we actually want to breed them, we need to provide some actually slanting that piece of marble or the glass or the asbestos sheet, so that they lay egg. This is the egg laying stage. You are observing that the female, they are laying egg one after another, and also male it is they are actually fertilize them. And here you see that same thing I'm just showing here. Also they lay egg in the over the actually the thermocol sheet also. Here actually the entire thing that that sticky egg we need to hatch them. Here I'm just one by one I'm just showing. Here angelfish, they are laying egg, you see, and male is waiting to fertilize them. Here all the egg they already they laid by the female, and this is the egg. And now this is actually here actually that that Marsco propagation technique, and here you see that thermocol sheet. Actually one cement cistern can be provided or the converted to breeding unit. How I just made them. Here actually what I want to say here actually that angelfish, they prefer to stay together only for entire life, and that's why we need not to disturb them. Once they become the pair, we need to keep them so that we can get the more actually that production or the baby. So here actually I just arrange them. The cement cistern are being separated by the thermocol sheet and also the bamboo split, and so that each chamber one pair that angel it is released. And same technique you see here in the glass aquarium. Even also you can breed them also. And always actually pair wise we need to keep them in the separate aquarium or separate enclosure so that they will breed. Here actually when we need to release them, and they are actually that water should be clean, and also we need to actually always think about the ammonia content, and that's why it is actually what it has we have arranged here. You see here I just made a very improvised actually technique, the filter. Here actually synthetic will we can keep in a actually one this is actually that water bottle only. Inside that synthetic wool are being provided so that water will also clean them, and the baby fish are raising. This is the marketable size of the angelfish. And also, yeah, here actually the seed production, how I can, how will breed the goldfish only. Here actually the breeding of goldfish. Here you see that the breeding of goldfish also very easy, and also many literature, though it is available, we need to inject them, but I generally not use in the in my actually career in the last I can say that 35 years I'm doing the goldfish breeding also. Here you see that what it is required, we need to proper that mature the male and female goldfish. And here also in the community tank we can also breed, and also individually also we can breed. Here in the cement cistern, here that different many pair of the goldfish are being released, and here we have provided that is actually the breeding mop, that is only the nylon thread only. Here that egg. Here actually one you see this is the cement system what I mentioned there. Here that different pair of the goldfish. Here that breeding of mop we need to provide them, and they generally breed in the monsoon, actually winter season, when the temperature it is low, that time only. And you see the next day morning you will get the egg attached with the substratum, and you see the attached egg only. And also for hatching also there is nothing is required, easily we can hatch them also, just simply provide in a actually tub, and this is the hatchling. And also this goldfish we can raise for actually the marketable size. In the pond also I raise here successfully, I raise in the nursery pond, and also in the pond by actually arranging some hapa also we can raise the goldfish without hampering the culture of the fish what it is going on in the pond. And here also we can cement system also we can raise the goldfish also. This is actually when we raise the along with the carp spawn. This is actually the whole of the carps actually fingerling and also the goldfish. And here actually the pure goldfish when it has raised, that is the marketable size. And also the koi carp also it is very easy. And breeding that koi carp. Here actually you see that here we need to provide some substratum like the goldfish. Even we that if the koi carp also remain present in the pond also, if we provide them some of the even this as a breeding mop, they easily they can also breed in the mop also. And in cement system also easily we can breed just like goldfish only. And in case of albino shark, that is that labio bicolor or labio erythurus. This is actually the labio erythurus rainbow shark only, and this is the labio bicolor. That this is called red tail shark. This fish need to breed. When we need to breed, we need to inject them, and generally that male it is required just 0.2 to 0.25 that is ml per kilo body weight, and in case of female, it is required 0.4 to 0.5 ml per kilo body weight. That any kind of synthetic hormone we can use and for breeding of this fish. And this hormone injection, you see, and generally we need to inject by using this insulin syringe only, and so that it will be very easy to inject them, and for as their small division it is available. And also in this fish, if we arrange some circular tank, that is important actually, and they are very small actually. 7 cistern circular tank are being used, and here also that water are being circulated using the same water only, and here in this way we can also breed them. And also if we hatch them also with this improvised model, also we can easily hatch them by using this water bottle only. This is actually helps just like a glass jar hatchery, so that easily we can hatch the fish egg. And also I work on the blood parrot, so that parrot fish, though it is a hybrid fish, and but I have tried and also successfully breed them. And for breeding actually we need to provide them some of the flower pot. Here actually I arrange some flower pot. We see that here actually male it is always brighter in color, and female it is some dull color. They are laying egg. Here you see, and also here after laying egg, generally male they just fanning them, or the parental care they are provide, so that egg will it will actually hatch, and also they always trying to clean them also. Here actually the offspring of that blood parrot. Here another fish also I have tried and successfully bred also, that is the green terror. This green terror also very important fish. You know, this is a very costly fish also, even 100 to 200 rupees a pair easily. So easily you can breed, and also you can earn, and very small investment and small actually space it is required. And here actually male it is larger in size and also bright in color, and female it is dull color and smaller in size. Here easily you can separate from the male from a female. And here actually one just tub I just use here, that male and female we are observing, and here you see that female they lay egg in the bottom, and same thing also they will provide some parental care, just fanning and all these things what male generally done. And here you see this is the then automatically it will hatch, and also after 4-5 days, then when they are free swimming, that time only they are taking plankton, small plankton. Also if we provide them, that is enough for raising and plankton. And also in the year stage grow up stage, after 15 days we can also provide them some also TB fix one, we can also provide them. And also this is the breeding of discus and discus fish. Here you see that this is the cone, it has I have provided here the male and female. Male, this is the brighter color male, and this is smaller size, it is female only. That here the another stage I have just provided the little advanced stage, and here that male and it is the female. And here actually some time of some precaution also you can keep them. And here incubation, that is that fertilize egg, and during that only, and also sometimes parent may also disturb the attached egg, and that's why here actually some barrier are being used, and so that that they cannot come to the closure, and also with their fin, and sometimes the egg may fallen down, and that way just we need to keep separate. And also here some another advantage that you see here that here already hatch out, and hatch out here actually all the hatchling or baby fish they are sticking. And next stage when it is the pre-swimming stage, and that time they only they will take their food from their body or the mucus of the parent fish, and that's why they are actually after their parents only. Here already you see that they are eating, and also free swimming stage already started, and also growing advanced stage only. And here also you can say this is the marketable size of the discus fish. Another fish also I have tried and also successfully bred, and also this is a very good fish for actually small scale investment and all small scale entrepreneurship development. The Coricat, it is the Coriodorus aeneas, and very why it is I am telling it is a small investment it is required. The fish where they are staying, it is the cement cistern only. We can easily raise them in the cement cistern, and only after 2+ year age they will lay egg, and it will continue another 3-4 years. And here actually what I want to say, they did not require the separate environment, only the same environment. Only thing we need to in the during breeding season, especially during the winter months when temperature cool down, that time only we need to provide some of the, actually some that polythene filled up with the water, and we need to hang them. Same thing are being made here, and here actually they will lay egg, and same egg, and you need to hatch them. This is the entire actually how actually it has bred the fish. Here I just say here see that male and female. Already I mentioned that female it is larger in size and male it is smaller in size. Here that same thing that breeding in cement system, that polythene actually that year only that bag what I have provided there, and egg it is attached. You see that attached egg. Only if we keep them, only it will automatically it will hatch. And this is after hatching only that hatchling are collected and raised also by providing when they start feeding only. We can start with the small zooplankton or infusoria also we can provide them so that easily we can raise them. And here actually some environment from research point of view, I can mention here actually that cement system where we need to raise the fish, that cement system must be rough. That wall should not be the polished one. If you polish them, some of these many that breeders they can lay egg in the cement system only. So it has make that rough only. And this is actually the feed of the small actually baby fish, the Artemian fly or Daphnia or tube fished worm also we can provide them. And in some cases in tube fished worm also in the we actually paste them, and sometimes juice also you need to provide them so that baby fish they easily they also enjoy. And this is actually the breeding and larval rearing of the our live bearer. So live bearing fish, they are actually what they are doing that even the parents they can eat their baby. Oh, that's why we need to keep in a brood cage, so net cage, so that baby fish will come out, but this mother cannot or father, their parents they cannot catch them. So here actually the brood cage, and here actually we need to keep the brooders, and so that after that we know that these live bearers means they directly give their birth of the young. So young automatically they will come out, and so that parents cannot eat them. And how we can separate them? Already I have mentioned the male they are having the gonopodium. Here is that same that net cage or brood cage where we need to keep the parents, and automatically they that offspring they can escape and they will come out. Here also another arrangement in the glass aquarium I made, where here also same purpose for breeding of the live bearer. Easily you can visualize they will lay their baby and baby will come out, and also in the mud pot also by providing some weed also we can breed them. Here actually the mass scale breeding it is going on. That one view I just providing here. Every day morning or evening we need to collect the baby, and we need to keep in the only nursery only where you can raise the fish. Yeah. Here also another that some breeding actually the nest builder fish. Here here actually the fighter fish, we can breed them in this technique only, on bag only, and they are only one pair. We just keep them here. Now I'm coming to the ornamental fish, how that livelihood it has maintained by utilizing the breeding and other actually part by using this ornamental fish. So here actually so many people they are they depend on also some that wild caught, even some rearing, breeding, seed production, fish trade, live fish. So different options they are used for the year only. The hobby of the ornamental fish keeping is gaining popularity in the country, and it is estimated that about 1.25% of the urban household are keeping the aquarium. And throughout the India, near about 150,000 families are involving in the fish rearing and culture industry, and it is estimated that about 20,000 families involved in the ornamental fish business in the West Bengal, including breeding, rearing, feed preparation, decorative material preparation, aquarium making and marketing, and their average monthly income per family 6,000 to 12,000 also. This is actually the some actually they involve in wild collection only. Especially I work there in the northeastern states, and you know that northeast it is the hotspot biodiversity of the native freshwater ornamental fish, and already I have recorded there 250 that indigenous ornamental fish, and also Indian trade also mostly depend on the export trade, particularly for the wild caught, and that is from the northeast only. And there are good number of people they have involved by only the wild fish collection only. And these are the collection and trading of the indigenous ornamental fish, though different the ornamental fish that chada or pakal or the kakle, so different fish species they are collecting and selling in the trading market. And also the breeding and rearing of ornamental fish. I already mentioned that at least in the West Bengal, in Howrah district only, more than 20,000 families they are busy with that breeding and rearing of the ornamental fish. So here some photographs and cement system for ornamental fish farm. Here you see that every household in some area in the Howrah and South 24 Pargana district, they are doing breeding. And pond-based ornamental fish also it is there. Here in the pond, without hampering the their normal culture, they fix some actually some net cage that they are using the net cage for breeding of the fish and the rearing of the fish also. Here you see some more view. Here actually that net cage they have used even in the top. They have used some net so that the birds cannot actually can eat the actually that baby fish. And breeding and rearing of the live bearer, that is another actually option. And here actually the colorful guppy or short tail or molly platy are being raised and also marketed. And there are also many people they have used by breeding this fish. Another breeding and rearing of the egg layer, there I already mentioned that angel and also goldfish and sarpetetra and pearl gourami, red tail shark and koi carp also very good demand both in the domestic market and also the international market also. And another also many people they are also involving in the aquarium making and trade also. You know, aquarium making and trade also is a very good business, and also very easy to prepare them also. One person he can easily prepare 20 aquarium in a day, and also they can also earn a very good amount of money for their livelihood maintenance. And aquarium accessories making and trading also it is very important actually vocation, especially the women. And you see here this our auntie, you can see that old guy, it is 72 years old, but even then she is active and also she is earning some money and for supporting their livelihood. Here actually they are busy with the assembling of the plastic that toy what it is used in the aquarium industry. So raw actually material it is manufactured in the industry, and same thing they are assembling in a home only as a actually that for maintaining their livelihood. Here, these kind of things also many you can see, especially in the Howrah and Hooghly and South Chowbish Pargana district in West Bengal. Here also you see that many that women group, they are busy for actually arranging the plastic toy. Another actually what I want to mention that aquarium plant propagation and trade, that is another option for maintaining the livelihood. Here actually the different kind of that aquarium plant are being actually cultured and also collected, that Bellicinaria, Cabomba, Echinodoras, and that they are collecting and also selling in the market. This is the view of the two, actually that view I'm just showing. One in this is our Gulf Street market, indeed, or Hathibagan market, popular in Calcutta. It is almost 300 years old, and here you see that many people, they are involved just for selling of this aquarium plant. It is grown in the different kind of wetland. Here is hydrilla also are being used, and here I can say one piece it is 5 rupees, and in the Calcutta market even hobby shop 25 rupees. And same thing also it is going to the, I have one survey also I made in the Kurla market in Mumbai. There also have seen even that one bundle of that, that is 200 rupees. So that's why this aquarium plant also a very good market, and now many people they are culturing just like paddy in the field, and they are actually earning a good amount of money by trading of this aquarium plant. So now another option, you know that aquascaping also it is popular, and many people now they are also trying to raise this. Already we have trained them that many of our students, they have also started this aquascaping business, and we know that aquascaping it is a now very good business in the ornamental actually trade. So live food culture and trade, that is another option. And you see even that our mosquito larva, that is also very good food for the ornamental fish. And also the TB fish, that is also another, even like the red one, that is also another option. So same thing, even plankton also, that also we can also culture them, also trade them, and same thing also many people, they involve with this trade for culturing and trading of this live food.
Sir, your voice is bit not very clear, sir.
Sir, your voice is not audible, sir.
Not audible? Why?
Yes, sir.
Then what can I do?
And now it is fine, sir.
Fine. Or network actually fluctuating then, yeah. Now I'm audible.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Yes. Okay. Artificial food preparation and also trade, that is another option. And we know that already various research institute it has developed the feed formula, and also our CIFE Central Institute of Fisheries Education, we have also developed the feed formulation, and also same thing also we have trained them, and many students they have also farmer, they have preparing their own food, and also same thing also sometimes they are marketing. So that is also another option what I want to mention. And trading of ornamental fish, that is also another option for livelihood. And this is actually the Gulf Street market in Kolkata. Here I'm just so many people they are involved for trading of the ornamental fish. Here you see the different ornamental fish they are trading and they are involved. And this is weekly market, and another market it is there in the Howrah area, that is daily market. And these two market I can say every day at least 45 to 50 lakhs are traded there for in the ornamental fish business. So that's why, and various people they have mentioned actually they maintain their livelihood with the different vocation. Here some people they are doing only some packaging. Here also these people is supplying the oxygen only. So different people they are involved with the different they are actually stake. So what I can say, the ornamental fish trade with a turnover, it is though it is the very that 6 billion and annual growth rate it is 8%, but our contribution it is very less. It is less than 1% only. So that Indian ornamental fish sector is small, but it constitutes one of the vibrant subsector of the fisheries and aquaculture. The major part of the export trade is based on the oil collection from the northeastern region, what I already mentioned. And out of 250 ornamental fish, and I have made some survey that is 155 species regularly exported, and many are also considered very potential. So there is a very good domestic market too, which is mainly based on the domestic bred exotic species. And the overall domestic trade in the fish in this field across that 1,000 lakhs and is reportedly growing at the rate of 20% per annum. The earning potential of this sector has hardly been understood, and same has not been explored at a technology driven manner. So there are actually some marketing channel that what I mentioned that our collector and unregistered trader, seller and exporter it is going on. And constant in the marketing of ornamental fish, we know that poor infrastructure and still there in many places, and market imperfection also it is there, and imperfect market situation and dissemination of the market information in obviously low, and also the export base in Kolkata and Howrah, Mumbai, Chennai, Trivandrum and Chennai, and the ornamental fish marketing system are not organized. And also research advancement, that value addition of fish, it is also essentially required. And the Chinese started a selective breeding of the goldfish from the year 1000 AD, and to begin the new strain of the goldfish. And selective breeding of the fish and developing new strain of the ornamental fish is a common practice, but in India, this technology not yet popularized, and hence the indigenous ornamental fish are not accepted in large scale and due to the less attractiveness. And this is issue the value addition, what it has already done. That is the Caraces, Soretas, all these goldfish, what we are presently, what we are enjoying, that is all the valuated one, that is not the original one. And likewise, also the koi carp also, you see that koi carp and most of the koi carp, it is all the valuated, and the original koi carp, it is you see that very actually that for ordinary look, but the valuated one, it is very attractive one. Our rosy barb, that Puntius conconius, also it is a very value added, and also different kind of that aquarium stain also it is available. And also chada nama, and you see that glass fish, what I mentioned, that same thing also it has value added in the. And also the zebra fish, you know, this is a zebra fish. Zebrafish is a Brachydenio rareo. Here all the aquarium strain also it is available, but this is our germplasm, and this is our original one. This valuated one, it is developed, and also now that trade has been realized. Those who have developed, they are only realized this trade, but where we are poor. And also another actually that angel, you see these are the different actually valuated angels are available. This also we can breed them because this is commercially very important, and also different kind of that high value of the angel fish are available that you can also breed them, and also we can realize the actual value of the trade. Here actually the discuss also different varieties of discuss it is there, and it is the red turkeys and pigeon blood or cobalt or Marlboro red, ring leopard or snake skin. So different also tangerine red. These are the different actually there's a discuss species that variety and it is there. Also issue of sustainability of the livelihood security, and also breeding of this ornamental fish. The breeding ground of the all important wild ornamental fish species should be identified and declared the sanctuary, and also institutional support it is required, and regulate the entire process of collection and marketing, that is also important. So different issues are there. So different that proper quarantine and introduce the when we are introduced to the some exotic fish, that is also important. and only few species are only bred in captivity, but lack of complete package of practice of mass scale seed production, many of the species, because we have plenty of germplasm resource. I already mentioned that 376 freshwater species and more than 700 marine ornamental fish are it is there. So if we just breed them and propagate them, then we can also lead to the global industry in the ornamental fish. Then status, now I'm coming to the actual status of the Indian ornamental fishery resource in the global perspective. Here you see, here the global perspective, if you see, then our position out of 10 fish, even we are having the 2 position, and in the global expecting most tropical ornamental fish. And you see, even one fish it is $10,000, even Australian flathead perch it is $5,000. Here these are the fish it is available, and also the most beautiful marine ornamental fish. They are also 4 position we are having. The first position, 3rd position, 7th position, and 8th position we are having. These are the fish species. And also among the most beautiful freshwater ornamental fish, they are also having, we are having 1 position. These are actually the gourami. And these are actually the most popular fish species for export, and different fish species what it has traded. And here actually the most demanding that indigenous ornamental fish and the trade in the overseas, that's marine fish and freshwater fish. Also that's Chana barca and different, even our Tetradon Cutcutias, Catopega sargas, and also Puntias denisoni, Etroplas suratensis. So different fish species are it is there. Indigenous ornamental fish and indigenous freshwater and marine ornamental fish. Now different stockholder in ornamental fish sector, we know that this sector, that's a different kind of input also it is there. These are the input sector, and this is the technology sector where the researcher, scientists, fisheries institute involved, even state department also involved, and marketing also, wholesaler, retailer, commission agent, hobbyists are there, even the financial organization like MPEDA, NCDC, NABARD, even NFDB, and also financial institution, trading institution are there. Now that I have made the SWOT analysis of the ornamental fisheries in India, that you see that what strength we are having, the biodiversity hotspot, and also the increase in number of the breeders or producer, variety of species within different agroclimatic condition, and sellers market, and weakness, availability of the resource, various research institutions and organizations, keen interest of the funding agencies, depending on natural collection. And these are different actually weakness points are there, and also opportunity. Also you see what opportunity is there, favorable government vision and scope of developing breeding technology, initiative of green certification, private sector keen to join the ornamental fish marketing chain, unlimited scope for expanding market, increasing awareness among the consumers on variety and quality, and threats it is there, even unorganized sector, even destructive exploitation, threats from the extinction of the indigenous species, and unexpected natural that calamities. And now that strategic framework for the holistic development, that ornamental fish production, what it is state need to take, the standardization of the breeding technology of the species in demand, quality management, awareness of scheme and promotion activities, dissemination of new technology and information, and ornamental fish marketing, what to do, that post-harvest management, packaging practice, transportation, marketing infrastructure, market information and intelligence, and under there also what it is required, the development of new technology it is required, and government also that regulation and promotion and subsidies and incentive it is required. So different kind of that. So that different aspect what I have mentioned, and from my actually study and also my actually personal experience, what I feel the ornamental fisheries can be given a serious thought from all concerned stakeholders like fisher folk, exporter, importer, Panchayat member, teacher, student, scientist, and top level planner in order to sustain the growth of the new sector of fisheries as well as for the better employment and foreign exchange earning from the state. Thank you very much, and I will be happy to answer any question. Thank you.
Thank you, sir. Thank you very much, sir. Sir, thank you very much for sharing your experience with us. Sir, and then you also covered the session of ornamental fish breeding with lot more information on different varieties of ornamental fishes, and also mention how to identify sexual dimorphism as mentioned above, and the characteristics of the male and female fishes. Dr. Mahapatra sir also discussed the domestication and maturity of the ornamental fishes, also explained habitat of the simulation also. Sir also mentioned that the breeding and larval rearing of the ornamental fishes, also discussed koi crab breeding and the larval stage. Sir also covered that hormone injection, how to give the fishes, it also discussed, and also covered the how to ornamental fish breeder is covering like 1,50,000 families involved in the ornamental fish business. So also discuss that aquarium plant propagation, how to trade it, and marketing, and also the export and import business. Sir, also thank you for covering the marketing strategies to like to market the ornamental fish. Sir, also discuss how to overcome the like the farmer will get some problems and how to overcome it, and how to like do the import and export business. Sir, thank you for the discussion is like open for the participants. The question and answer discussion is simple, but please share your question in the inbox section. We will give the answer. Please like in the inbox question, so that I will give the answer. Is there any question? Anyone want to ask question?
There is no question, madam.
Yeah, sir. Okay, everything maybe they understood. Okay, thank you, sir. On behalf of Marsco Aqua Center, Baleshwar, I would like to thank for giving your presence and covered beautifully the topic ornamental fish breeding session. And if the participant give the question, then we will forward it to the number, so that after the session we can share with the participants. Now that they didn't give any question, so.
Thank you. Thank you,
Yes,
madam.
sir.
And thank you, everybody.
Thank you.
Thank you to and regards to all my participant and friend and also organizer who have given me the opportunity. Thank you, sir. Thank you. Thank you, everyone. Thanks and regards. Namaskar. Namaste, sir. Namaste.
Thank you, sir. Thank you very much, sir.
Thank you, sir.
Yeah, after the first session, we'll go for the second session. I would like to welcome Dr. Amerneni Ravi Kumar, sir. Sir, you are welcome to Marsco Aquatic Insects Center webinar, session 2. I will introduce you, sir. And Dr. Amerneni Ravi Kumar is an aquaculture consultant with 26 years of experience in various aspects of aquaculture. He has master's degree in aquaculture and PhD in stream pathology. He also founded Ravi Aqua Academy and partner in Alpha Biological. Is a fish and stream disease diagnostic laboratory in Nellore, as well as a partner in Blue Star Marine Stream hatchery. He conducts field trials on aquaculture chemicals and feed supplements. He is consultant to several hatcheries and stream nurseries and routinely conducts training programs on various aspects of aquaculture in India. India as well as in international exposures also, Bangladesh and Iran. Sir also uses social media, YouTube to reach out the abroad audience on aquaculture technology and as well as in the Indian farmers also. Sir, you are welcome to Marsco Aquarium webinar. Sir, you may start your presentation. Please welcome, sir, Dr. Amerneni Ravi Kumar. Gautam, please unmute Ravi Kumar, sir.
Can you hear me?
Yes, sir. Yes, sir.
Okay. So thank you very
Yes.
much, Sushreka, for the nice introduction. I would like to thank the organizers, Mahinder Bola Marsco,
Thank you, sir.
Manage and NFDB for giving me this opportunity. And first session, we had a very beautiful session on beautiful fishes. Sir has covered several species, but I am going to cover only one species, that is Vanamy. And from Sar's presentation, what I could understand is not only in humans, even fishes also, males are beautiful and handsome. So let us go. Can I share my screen?
Yes, sir. Go ahead, sir.
Just a moment. So before going to the presentation, I would like to know my audience. How many of you are students? Please type student in the comment box. Type student in the comment box. Chat box is there. Please type student in the chat box. No students? Just a moment. Very good, very good. Can you see my presentation? Can you see my presentation?
Not yet, sir. It is coming up. Yes. Yes, sir. If you could make it full screen, thank you, sir.
Yeah, just making it, sir.
Thank you, sir.
Okay. It's visible now?
Yes, sir.
Okay. The topic I'm going to cover is on Litopenaeus vannamei, shrimp farming. You know, the Indian shrimp farming industry started with two species. One is Penaeus indicus, white shrimp, and the other one is Penaeus monodon, tiger shrimp. But after 2003, Vanamy was introduced for experimental basis, and 2009 it was open to all. So from 2009 onwards, most of the farmers from monodon they converted to Vanamy. So why they converted to Vanamy from monodon was there were several problems like white spot virus, not availability of specific pathogen-free broodstock, other diseases like white feces, loose shell, and external fouling. Because of all these problems, almost more than 90% of the farmers, they shifted from monodon to Vanamy. Now, in Vanamy, we have the same problems. So again, the people are thinking back whether to go for monodon or go for Vanamy. Several people in India now, they tried monodon and they got very good crop when compared to Vanamy. So now the topic was given to me is on Vanamy culture. So I'm going to continue that. So the major challenges in Vanamy farming are white spot syndrome virus, white feces, EHP, a fungal pathogen, enterocytosome hepatopene, RMS, running mortality syndrome, and Vibriosis. These are the major challenges that we are facing at this moment. So I'm going to cover all these problems, how to manage all these problems in my next few slides. So the basic steps in Vanamy shrimp farming are pond preparation. Then after pumping water, you have to treat your water. You have to culture your water for the bloom development. Bloom means phytoplankton bloom, and then zooplankton. It's a natural food like mother milk. And then we have to go for very good quality seed. Seed selection is very, very, very important in shrimp farming. So it plays a major role in the success of shrimp farming. And then feed management and health management. Let us discuss all these steps in detail. So coming to the pond preparation, we have to dry the pond for 21 days minimum. Why we have to dry for 21 days is, so as per the available research, white spot gets inactivated if you dry the pond for 21 days. Earlier we thought it is 4 days, but the research conducted by SIBA shows that if you dry the pond for 3 weeks, 21 days, white spot get inactivated. And then we have to remove the sludge. Removal of sludge may be immediately after harvest or before starting plowing of your pond. So either way, you have to remove your sludge. If you are not removing your sludge, just 1 minute. Sorry. So, and another step in pond preparation you have to keep in mind is 95% of the Indian shrimp ponds are affected with EHP spores. So you have to take care of EHP spore inactivation. This is the most important step in pond preparation. So in order to inactivate EHP, there are certain suggestions like liming. So for one, the first suggestion is application of calcium oxide, burnt lime, at 6 tons per hectare. So you have to apply 6 tons of burnt lime per hectare before pumping the pond. Then another treatment that farmers are following is application of alkali and acid treatment. So alkali, they use sodium hydroxide, and acid, they use hydrochloric acid. 3000 ppm of sodium hydroxide and 3000 ppm of HCl. So initially they add alkali. It increases the pH above 12, which inactivates the EHP spore. And then to reduce the pH, again, farmers are adding acid at the same concentration. And now, of late, the recent research shows that, research conducted by Mahidal University shows that by applying bleaching and potassium permanganate also, we can inactivate the EHP spores. So the dosage of bleaching powder that was recommended is 40 ppm of 65% bleaching powder. 40 ppm of 65% bleaching powder. 65% bleaching powder, we call it as high strength hypo. So what we do is we pump water for half feet, then we apply 3 bags of high power bleaching or 6 bags of normal bleaching. Both are same. I'm repeating once again. Fill your pond for half feet, then apply 6 bags of normal bleaching or 3 bags of high power bleaching. Then after 48 hours, apply around 12 kg of potassium permanganate per acre in the same water. So after 48 hours, you can start filling the pond for water filling and water culture. So this way we can inactivate the spores. This is the structure of EHP spore. You can see the red color one is called as polar flagellum. So what we do is when we apply chemicals, if the polar flagellum comes out. So once the polar flagellum comes out, it is no more infective. So all the chemicals, what we are applying is to extrude the polar flagellum. So then this is the liming application. So 6 tons of burnt lime application per hectare, then pumping. So immediately after pumping, the pH increases to 12. Then gradually after third day, it comes down to normal pH. So this is, we already discussed about 3000 ppm of sodium hydroxide. Then very next day, 3000 ppm of hydrochloric acid. So you can also check the pH of your pond after application of sodium hydroxide. So you may not bring the sample to the lab. Simple paper with pH paper, you can check the soil pH. If it is crossing beyond 9, your system is okay. And then bleaching powder, as we discussed, pump half heat water. Apply bleaching powder only in the evening, because the bleaching powder chlorine is photosensitive, light sensitive. So avoid light hours. That is why we apply bleaching powder always in the evening time. So exactly after 48 hours, we go for potassium permanganate. The same water is sprayed on buns. Now we are inactivating the EHP spores that is present on the bottom. If you spray the same water on the buns, so you can inactivate the EHP spores that are present in the buns also, so that you can get a very good crop. So we are applying several chemicals to inactivate EHP spores. So soil is losing its naturality, its vitality. So how to activate the soil once again? Suppose if you check 1 gram of soil, it will contain 10 to the power 5 to 10 to the power 6 number of bacteria. So by applying all the chemicals, you are reducing the diversity of the soil. So you have to condition your soil before stocking your pond. So how we condition is, we apply symbiotic or probiotic. Symbiotic is we use rice bran, and probiotic in combination with the sodium bicarbonate or any other buffer. We ferment it for 24 hours and we apply to the water. So like that, we apply for 7 days before stocking. So within 7 days, again the bacterial count goes back to 10 to the power 6. So then we also get a very good amount of zooplankton and phytoplankton, which is a natural food. Then water treatment. So we have different water sources. Different water sources needs different water treatments. As a student or as a consultant, you should study the water source and the threats associated with. For example, if you are using a creek water, there is a threat of pathogens or fish or weed shrimp. If you are using a bore water, there is a chance of ammonia, hydrogen sulfide, iron, etc. Based on your water source, you have to design your water treatment. In general, suppose if you have a suspended solids or settlable solids in your pond, pump in a reservoir, leave it for 1 day. So all the settlable solids will settle down. Then if you have suspended solids, you have to pass through it as a filter system. Maybe in the farm, we can go for filter bags or HAPA. So after filtration, you have to go for disinfection. Suppose if you are using chlorine, if you are using canal water, you have to go for disinfection. For disinfection, normally what we use is chlorination. Chlorination can kill all the carriers. It may not kill the virus directly. It kills all the virus carriers and all other weed fish and weed shrimp also it kills. So depending upon your water source, you have to go for your water treatment. So after dechlorination, you have to try for water culture. Water culture means development of bloom. This we have already discussed. So water culture. During water culture, we apply different organic and inorganic fertilizers. If you go for inorganic fertilizers promotes phytoplankton based on the ratio of nitrogen phosphorus ratio. It develops sometimes. If the phosphorus is more, you get more green algae. If nitrogen is more, you get more diatoms. Sometimes we also add silica to activate the diatoms. So we also go for organic fertilizers. Sometimes we go for organic fertilizers like rice bran and groundnut tile cake fermented with the probiotic. Also, some farmers are going for organic fertilizers like cow dung, etc. So all these fertilization initially develops phytoplankton and then zooplankton also develops. So if you have a very good zooplankton, white feces instance is relatively less in a pond where there is sufficient quantity of zooplankton. For me, the sufficient quantity means 2 to 3 ml per 50 liters of water. If you take a HAPA filter, if you collect 50 liters of water and pass through a plankton net, if you get 2 to 3 ml of zooplankton in it, that means you have a sufficient plankton. So clear till this point? Type clear if you are following. I don't know whether you are able to follow me. Please type clear so that I can understand you're able to understand. Is it clear so far? Hello?
Yeah, the chat messages are saying clear and yes, sir. Go ahead,
Okay.
sir. Thank you.
Thank you. Thank you. Thank you. Sorry, what happened? Okay, so another important aspect in shrimp farming is selection of good quality seed. So in general, bigger the better. So and size variation should be less than 15%. If you take a bigger seed, naturally size variation will be more. If your seed is less than post larvae 10, it is acceptable up to 10% of CV. If it is more than PL12, up to CV of 15 is also okay. And as far as EHP is concerned, if you check the post larvae, there is around 80% chance of missing out. If you check the fecal matter of broodstock, there is a 80% probability that it gets detected. And in PCR, it's always better to go for white spot virus and IMNV, and Vibrio should be less than 100 and 1000, 100 green colonies and yellow 1000 colonies. So as a farmer, when you go to a hatchery, we have to look for the activity of the shrimp, whether it is active or not, any color change is there, any blue color or red color larvae are there, any mortality is there in the tank. And another important thing is color of the hepatopancreas. Color should not be pale. The color of the hepatopancreas changes with the feed they are using, and it should not be pale. Based on the feed color, color changes, but it should not be pale and small in size. So behavior, suppose if there is a heavy necrosis, they cannot walk normally and they lie on one side. And you can also go for counter current test. So if larvae are active, you can select that particular batch. And another important quality parameter is weight. So number of shrimp per gram. Earlier it was around 500 numbers per gram. Now the standard is minimum it should be 300 numbers per gram. So I told you earlier, bigger the better. So select the bigger seed, it performs better. And you can do the stress test. How we do a stress test in the hatchery is, we collect seed in a basin, then directly put all the seed in fresh water, 0 ppt water, wait for 30 minutes, count the mortality, and then transfer them again back to 30 ppt salinity. Wait for half an hour, and after half an hour, check for the survival. If the survival is more than 90%, you can confidently take that seed. And then another important thing is everybody wants first batch or first batch seed. So it's not always correct. Going for the first batch is not always correct. I will explain you in detail. Suppose if your hatchery imports a particular batch in January, it is a first batch. Again, in February, if they import another batch, again the January batch, they call it as first batch. If you want to always want seed from the first batch, means it is from the January batch only. And again, every shrimp spawns around within 10 to 15 days. So they keep on spawning. So it's not always correct to ask for the first batch. You ask for a best quality seed, not the first batch seed. And after after going through all these steps, you can send it to the lab and pack it on the same day. So in the lab, we will check for all the pathogens. Immediately by evening, you have to pack. Why I am telling you, even in our hatchery, within 24 hours, there is a drastic difference in the quality of the post larvae. Sometimes Vibrio flare up like anything. Within 24 hours, you won't believe your eyes that the same batch of seed you have seen yesterday. So what I am suggesting you is you pack on the same day of testing in the lab. So this is the activity of this. This is very weak seed. You can see congregated, settled in the middle of the basin when you spill the water. On the other hand, this is excellent seed. You can see all shrimps are moving against the water current. And another important factor is there should not be any blue shrimp. Of course, this is not post larvae. This is juvenile. But even in post larvae, there should not be any post larvae in blue color. Red color is also a bit accepted, but if it is there in blue color, better to reject that batch. And then look for color of the hepatopancreas. You can see all the hepatopancreas is normal and full. There should not be atrophy, should not be there, and it should not be transparent. And then size variation. You can see the huge size variation in this particular batch. So if the size variation is more than 15%, it is not acceptable. This factor we have already discussed. Weight of the post larvae, we call it as post larval efficiency. Post larval efficiency means tons, metric tons of final production from 1 million of seed is called as post larval efficiency. So then we have to screen for white spot syndrome virus, EHP, enterocytosome hepatopene, a fungal pathogen, IMNV, infectious myonecrosis, and IHHNV, infectious hypodermal hematopoietic necrotic viruses. All the viruses are there, but 100% of the cases you must go for white spot and EHP. And then after stocking, we have to focus on feed management. If you overfeed the system, early you get white feces very early. So focus on strict feed management. And based on the temperature and DO, you have to keep adjusting the feeding. One research shows that in the first 1 hour, there is 8% leaching of the feed. So the strict management, with the strict management, you can minimize the leaching so that all the nutrients goes to the body of the shrimp. And if you overfeed it, it's a feed for the Vibrio also. All the excess feed, fecal matter, it's a very good feed for the Vibrio. So if you are overfeeding your system, means you are feeding the Vibrio also, so that there is every chance of getting white feces or running mortality syndrome or other vibriosis. So vibriosis is all the diseases that are caused by bacteria. Vibrio bacteria is called as vibriosis. There are several types of vibriosis. So there is every possibility of getting vibriosis with overfeeding. And feed performance is very, very important. Feed performance factors like there are certain indicators of feed performance, weekly growth, and feed conversion ratio. So always your feed conversion ratio should be less than 1.5 for the with better management. So this picture shows that Vanamy is a continuously, it's a heavy eater. It eats continuously. You can see the length of the fecal matter, gut is full, stomach is full, and still it is eating feed. So Vanamy is a voracious feeder. So always keep in mind, you should never overfeed the system. So we also call it as gut evacuation time or gut retention time. If you overfeed it, they continuously eat, and the assimilation will be very less. So excretion will be more, assimilation will be very less. So factor influencing the feed performance are feed formulation. Not all feeds are same. Some companies they produce very good feed. Some companies are producing inferior quality feed that farmers can make out in the field. And manufacturing process is also different, physical properties and water stability. Nowadays, certain companies, they are not able to maintain proper water stability. A feed with the poor water stability leaches out fast, and FCR will be very high. And you have to handling and storage, you should store in a cool place, not under the sun. We'll discuss feed management in detail. And there are different farming systems like high stocking density. The modern shrimp farming, even people are going up to 150 pieces, 200 pieces per square meter. Some people are going for manual feeding. Some people are going for auto feeder. Based on your salinity, based on your water quality, based on your temperature, based on your aeration system, you have to adjust feeding. And based on the genetics also, you have to adjust your feeding. For example, certain strains of L. vanamei, they grow very faster. Even we are getting 4 grams, 5 grams, 6 grams per week. So based on that, you have to adjust the feed. Now, if you take at present Monodona, there are cases of 7 grams per week. So if you feed keeping target of 2 to 3 grams in mind, you may lose the growth. It's we have to allow it to grow to its genetic potential. If you understand this, you can go for a better. You can do better feed management. So if you closely observe this graph, if you go for underfeeding, FCR will be high. If you go for overfeeding, FCR will be high. So there is an economic optimum. Look at this particular range. So this is, we call it as economic optimum. Just take a screenshot, and there is a lot of meaning in this. So take a screenshot and try to understand this graph. It's very helpful in feed management. So if you overfeed, feed waste will be there. Water pollution will be there. Because of water pollution, ammonia, high biological oxygen demand, hydrogen sulfide will be there. So all these things cause stress to the shrimp. Stress causes immunosuppression. So they are prone to diseases, and you get poor results. On the other hand, if you underfeed the system, so growth will be slow, and protein is used as an energy. So ammonia is excreted. So more ammonia again with underfeeding. Again, you get high FCR and poor growth. So you should not overfeed and you should not underfeed. You should strike the balance. So this is the economic optimum. So you have to try to understand this particular point. So in tray-based feeding program, normally we go up to 30 days. Formal call it as blind feeding. In fact, it is not a blind feeding. It is a programmed feeding. So based on number of seed you have stocked, we have a program. According to that program, we feed up to 30 days. After 30 days, we follow check trace. Initially, we are deliberately programmed. We are deliberately giving an excess feed because all the shrimp larvae should be able to feed on it. And much of feed goes to the pond water and acts as a fertilizer and helps in bloom development. And during early stages of post larvae, they prefer natural food. That is why we suggested culturing, water culturing, to get a good quantity of zooplankton and phytoplankton. And better water quality, better feed quality, larvae grow fast and they start consuming feed earlier, so that you get a check tray control. So check tray placement is also important based on your feeding practice. Some farmers, they apply feed from the bund. Some farmers, they apply feed on a boat by tying a rope in the middle of the pond. And some farmers, they go for auto feeder. So based on your feeding practice, you have to place the check trays. And this is the check tray near auto feeder. Always you can see black fecal matter, small fecal matter, and very less shrimp. Now, why? Because we are not putting feed in the check tray. Only leftover feed is falling into the check tray near auto feeder. So there is a difference in check tray monitoring between manual feeding and auto feeder. Nowadays, there are acoustic sensors. They broadcast, they spread feeding based on the consumption and the sounds made during consuming. So they call it as acoustic feeders. There is one company in India, Airwaka, and this AQ1 is also very popular in other countries. Based on the sounds, based on the activity, they release feed into the water. So if you go for a check tray feeding, the color of the fecal matter gives a lot of information. Sometimes if it is in feed color, so it means that you are feeding properly. If it is in red color, it indicates that there is cannibalism in your pond. There is something wrong. Shrimp are dying. So other shrimp are eating the weak or dead shrimp. If it is green, they are eating plankton or benthos. If it is black, you can say that you are either underfeeding or H2S, hydrogen sulfide problem, is more in your pond. White feces, it naturally floats on the water and it's an indicator of a serious disease. And smell, sometimes it smells in feed color, or sometimes it gives very foul smell. Again, it's an indicator of a problem. And length of the fecal matter also, it's very important. Smaller the length, underfeeding, or longer the fecal matter, it's overfeeding. So based on the color and length of the fecal matter, you can decide whether to increase your feed or reduce your feed, or something is wrong in the health. So whenever there is a DO problem, or whenever the DO levels are low or suboptimal, the feeding goes down. You can see this particular case, white muzzle is there. This is not because of disease. This is because of low dissolved oxygen. When the dissolved oxygen is low, they don't take feed. So during that period, the shrimp comes to the surface. Immediately you have to suspend feeding. And even when there is a molting also, shrimp won't eat. So in periods of molting, you have to reduce your feeding. So every day you have to observe the check trays. Based on the check tray consumption, based on the behavior of the shrimp, you have to adjust your feed. And when this is a heavy molting, whenever there is heavy molting, few hours shrimp don't feed. So during that period, naturally feeding goes down. Feed is left in the check tray. You have to reduce your feeding accordingly. So normally some farmers, what they are doing is during feeding, just before half an hour feeding, they stop all the aerators, but they install few aerators in the middle of the tank so that there won't be any water current that is affecting feeding behavior of the prawn. Nowadays, farmers are also going for blowers, so they can continuously run the blowers even at the time of feeding. We have to stop only paddle wheels, and we can run either blowers or aerators that are there in the center of the pond, so that the dissolved oxygen fluctuations won't be there. All these fluctuations, they cause stress to the shrimp, which finally leading to the disease. So I'm going to give you a tip here. When you observe the heart of the shrimp, just look at this. This particular triangle part is a heart. If the heart is dark in color, it indicates there is sufficient oxygen in the system. Whenever the oxygen is low, or suboptimal level of oxygen or low dissolved oxygen, this becomes transparent. This dark black color won't be there in the heart. That indicates oxygen deficiency. So it's an indicator only. And aeration is required. Only 15% of the aeration is required for the shrimp biomass. The rest is for the feed and the biological oxygen demand. Approximately 1.2 kg of oxygen is required for each kg of the shrimp. And 1 HP aeration is needed for every 10 kg feed per day to maintain the oxygen concentration above 4 ppm. Now the standard is around, it should be above 5 ppm. So always you have to maintain sufficient aeration to maintain the oxygen levels above 5 ppm to maintain the health of the shrimp. And check tray management, as far as check tray management in longer ponds are concerned, so this is around a 20-acre pond, only one pond. Normally, what we suggest is 0.3 to 1% in the check tray. That means 3 to 10 grams per kg of feed in each tray. For example, If it is a 20-acre pond, if you stock 20 lakhs in that particular pond, and the body weight is around 50 grams, 20 grams, that means 50 count, we have to apply 900 kg each meal, each day. That means 225 kgs per meal. So that means every check tray you have to apply 2.25 kg. So that is not practically possible. So what we are doing is, so the total feed divided by number of acres. For example, this is 20-acre pond. We are giving around 225 kg per meal. So 225 we are dividing by multiplying 1% dividing by number of acres. I'm repeating once again. Suppose if you take 20-acre pond, if you are applying 200 kg of feed, that means 1%, that means 2 kg you have to apply in the check tray. The 2 kg divided by number of acres. So that much only you have to place in the check trays. Then only you get proper check tray feed management. So again, based on the genetics, I already explained you, there are different lines: genetic line, hardy line, and balance line. So suppose if it is a growth line, you have to give more feed. If it is a hardy line, you have to go for relatively less feed. If it is a balance line, you have to you have to go in between via media. And there is a much discussion on feed protein. Earlier, if you refer the earlier literature, people say that Vanamy needs less protein. Those days, Vanamy growth rates were expected around 1.5 to 2 grams. Nowadays, it is growing up to 5 grams per week. So if you give more protein, it grows better. If you give less protein, it grows very less. So if you go by the literature, it says less feed protein is required. But if you think practically, it needs more protein because it is growing very fast nowadays. And as far as health management is concerned, most important thing is biosecurity, water quality maintenance, probiotic application. There are different probiotics: soil, water, and feed. Different species of probiotics are used for different purposes. And nowadays, bacteriophages are also available in the market to control vibriosis. And it's a common practice in Andhra Pradesh now. Most of the farmers are using symbiotics. And as far as low salinity is concerned, you have to maintain the mineral balance also. So especially below low salinity, below 10 ppt, mineral application is required. We'll discuss in detail. And finally, we have to maintain the sediment quality also. Better the pond bottom, better the water quality. Better the water quality, better, less the stress, healthier the streams. So it's all the directly interrelated. So what is biosecurity? This is a definition. Just don't go by a definition. In practice, all the management practices we do to prevent the entry of the pathogen into our system and to prevent the spread of the pathogen once it attacks our pond. So all the management practices that we do to prevent the pathogen's entry and to prevent the spread of the pathogen, we call it as biosecurity. So different pathogens has different biosecurity protocols. What I am discussing here is to control white spot virus. So first of all, before pumping, you have to pass the water to different filters so that in order to avoid all the virus carriers like weed shrimp is a carrier, crab is a carrier, certain zooplankton species are carriers. So we have to filter the water before pumping. And after pumping, you have to apply chlorine. After application of chlorine, it kills all the weed fish. You can see here, there is a weed fish here. So then wait for 4 days. Then you can, in the meantime, dechlorination takes place. Some farmers are also using crustacicides, but it is not advisable. So this is a particular case. This picture was taken around 20 years back. You can see it's a monodon tiger shrimp pond, but they have not filtered the water properly. You can see indicus here. So indicus is affected with white spot, and then it was spread to entire tank. And in another case, it's an indicus. It's a Vanamy pond. You can see they have not filtered the water properly. Monodon came. Monodon got affected with white spot. Then it affected the entire pond of Untitled Vanamei. So the filtration is most important step in water treatment. And another important tip is farmers are bringing these plastic crates to pack seed. The same plastic crates that are being used to transport the harvested shrimp. For example, if the farmer harvested a white spot virus pond, they'll transport it in the same crate. The same crates without washing, they're bringing it to the hatchery for seed transport. You can see they're not washed properly. It's a very high risk. They came to hatchery, selected a good seed, screened for all the known pathogens, but during transportation, again, it got contaminated. Within 15 days, that pond got affected. The common practice when we send samples to West Bengal and Gujarat, we pack in thermocol boxes. There are two advantages. One is biosecurity. So there is no contamination in that, and it's lightweight, so easy to transport also. And another thing is, after bringing seed, this is I'll explain you this. There is just this happened in Nellore. One farmer harvested the shrimp a day before, and it was affected with white spot virus. And exactly after 24 hours, neighbor farmer got the seed, unloaded at the same place, and stocked. So within 15 days, this particular pond got affected with white spot virus. So it's very important. You have to follow strict biosecurity. Sorry, something wrong.
No, sir, it's going on fine.
Yeah, you have to take care of carriers of. So you have to irrigate crabs. Crabs are the carriers of white spot virus. So, for example, there is one particular pond affected with white spot, and there are crabs in that particular pond. Means they eat the shrimp. When you dewater that particular pond, when you harvest that particular pond, all the crabs they go to the other pond. So you have to do fence. You have to make a fencing before pumping, and you have to disinfect your pond. And there are certain other carriers like snakes, frogs, dogs, cattle, and etc. They're all mechanical carriers. And some crabs may enter through your inlet outlet also. This is an outlet. So a crab can enter via an outlet. So what we suggest our farmers is to close our outlet with a mesh so that all the carriers cannot enter into it. And birds are another risk. If you are going for a high density system, we strongly recommend the farmer to go for a bird netting also on the top of the pond. There are different birds. For example, kingfisher, relatively less threat. This is a kingfisher. It's relatively less threat when compared to crows. This is a crane. They eat only on the sides. So they eat only on the sides. This is a cormorant. They enter into the pond and collect shrimps and go to the other ponds. And highest risk is crow. Crow is most, if you look at the ornithology book, crow is the most wisest bird. So even with bird fencing, they can enter into the pond like humans, like entry gates. So the habit is they don't eat the shrimp there itself. They collect the shrimp, go to some other place, maybe they sit on the aerator float and eat in another pond. So crows plays a major role in spreading the white spot virus. And this is seagull. Seagulls are also relatively less risky when compared to crows. This is a picture that was taken in Kolleru area, near Kaikaluru of Andhra Pradesh. This particular pond was harvested with white spot virus. They have not removed the dead shrimp. You can see how many cranes are there. Naturally, these cranes, after some time, they go to the another ponds. So that is why a white spot virus outbreak is very, very high in case of Krishna district, Krishna and West Godavari districts. And ants also, they're relatively less risky, but they can also spread the disease from one area to another. All other insects like dragonflies, aquatic insects, all these are, especially in freshwater ponds, insects are more. If you harvest one particular pond with white spot virus, naturally they go to the other pond. So that is why the spread of virus in freshwater is more. One is because of birds, and the second is because of all these insects. And polychaete worms is a major reservoir of EHP, enterocytozoan hepatopene. They are also vectors of white spot virus. So most of the, even up to 15%, if you refer the latest research paper published by SIBA, most of the polychaetes in India are affected with EHP, a fungal pathogen, which is responsible for poor growth and partly white feces. And there are certain other carriers like net is a, if you are not properly disinfecting the net, so they can spread disease from one particular pond to the other. Snakes, turtles or tortoise. So another important point is nowadays farmers are going for polyculture. So in polyculture, especially in marine systems like milkfish, they're going for polyculture with milkfish. So when they collect water, when they collect milkfish from the wild, it also contains some wild post larvae. In our natural waters, you can find plenty of indica species or monocera species. Most of them are infected with white spot. So if you are not able to separate them properly, so in polyculture also you may get white spot virus along with wild post larvae. And another thing is when you transport the truck, you have to see that it should not drain water near ponds. So there is a particular pipe here. All the melted ice comes out from this pipe. So during when you are passing between ponds, you better suggest them to close this particular valve till they go to the highway area. So that is why we can reduce the we can minimize the risk of white spot virus. And some good management practices also suggested. So certain areas, they don't harvest the pond immediately after white spot outbreak. They try different chemicals. So when the mortality is high, then only they go for harvest. So they just, you can see the bags here, all the dead shrimps, they tie in bags and spread throughout the area. So that is why they are spreading white spot virus also. And another important factor is farmers are going for partial harvest. For example, the same net, if they use it day before for harvesting a white spot virus outbreak, most of them, they are not disinfecting the nets. Even they are not drying their dresses they are wearing also. So the same dress they wear without drying, and they enter into the pond for partial harvest. It's very high risky. It naturally spreads white spot virus to that particular pond also. So the persons who are entering also should follow certain guidelines, like washing their wearing gumboots and washing the hands and foot in disinfectants like potassium permanganate or iodophor. So in spite of doing all those things, if you still have a white spot virus, I suggest you to go for a crop holiday. In 2 places in Andhra Pradesh, farmers are going for crop holiday, Kavali, and there is one particular place in East Godavari. They are doing extremely well when compared to other areas. They are going for partial harvest. Fallowing. They stop crop for 3 months. So after 3 months, they're able to get very good crop. So that is another strategy. Only 2 areas farmers are following this, and they're able to get successful crop. And coming to the diseases, white feces and running mortality are the major diseases apart from white spot virus. So the symptoms are white fecal matter floating on the water surface, feeding comes down, size variation increases, poor growth, then loose shell, and gradual mortality. These are the symptoms of white feces. So this is one. Recently, I'll tell you a story. Recently, one hatchery invited me to their hatchery. They told that we have white feces in our broodstock. Then I visited that hatchery. They told again it's more in the early morning, and after first feeding, white feces is more. Then I asked them what feed you are giving in the morning. They are giving squid. When you give squid, naturally fecal will be white in color. So in fact, it is not a disease. It is natural. The fecal matter color is equal to the feed that you are giving. And moreover, if you put it in a glass of water, if it is floating, yes, it is a white fecal matter. If it is not floating, no issue. So people should know that white fecal matter floats on the water surface. It won't sink to the bottom. And white fecal matter was noticed in the 14th day of culture. This is the post larvae. Immediately after 14th day, we are noticed white feces. So there is a difference between white feces and white gut. Wherever you go in Andhra Pradesh, the people call it as white gut. White gut is different and white fecal matter is different. White fecal matter means fecal matter itself is white in color. White gut means gut becomes white in color. You can see here, its gut is very glossy. Here, gut is very thin and white in color. Both are different. Both are etiologies are different. White gut is because of the toxins produced by blue-green algae. They call it as hemocytic infiltration in the gut. So this is the shrimp affected with white spot, the white fecus, and huge size variation because of white feces and EHP combination. Then they turn to loose shell and grand mortality. So the regions, now the latest research shows that there is a particular anaerobic bacteria that is responsible for white feces. Initially, we thought EHP, then we thought EHP and Vibrio. Now the latest research by Mahidal University shows that there is one particular anaerobic bacteria, Propionogenium, is responsible for this white feces, and they're able to reproduce white feces with this particular bacteria. Earlier, people told that it is Vibrio and EHP, but they're unable to reproduce the disease by infecting the healthy one with EHP and Vibrio. And now everybody is pointing out Propionogenium is the bacteria that is responsible for white feces. And another research shows that the anti-nutritional factors that are present in the feed is also responsible for white feces. So they are able to manage by giving proper feeding, by good quality, by selecting good quality ingredients in the feed. They're able to minimize white feces. And with anaerobic bacteria, they're able to reproduce the disease. Now we know this particular bacterium is responsible for it. Now the diagnostics has to develop in order to go for a biosecurity protocol. We have to wait for some more time till we get diagnostics. And this is the bacterium, Propionogenium. It's an anaerobic bacterium. It's not aerobic bacterium. They're able to reproduce this white feces. And another most common disease is Vibriosis. Whenever there is a redness of the shrimp, people call it as Vibrio. Even in case of white spot virus, when the shrimp turns to red, people call it as Vibrio. But in most of the cases, it is because of stress. For example, if the water is turbid in color, shrimp is naturally in red color. So if you place the shrimp in normal water for 10 minutes, you can see a color change. If there is a color change, it is not a disease. It is just because of water quality. So not all the redness we cannot link to the Vibriosis. And coming to running mortality was reported in different states. It was reported in Thailand, it was reported in Indonesia, it was reported in Chile, but it was not listed in OE. Once the exact etiology and diagnostics are established, it will be listed in OE, World Organization for Animal Health. So the symptoms are, first symptom is red color antennae, second symptom is red tail. You can see red tail here. On the bottom, it is a normal shrimp. On the top, it is shrimp with red tail. If you observe the antenna under microscope, you can see this is normal antenna, and this is a red antenna. So the first symptom of RMS is antenna turns red, and second symptom is tail turns red. Third symptom is hepatopancreas turns red. So, and in some cases, you can see legs, particular part of leg turns red. There is a specific chromatophore pattern. If you look at in the middle, this is a normal healthy subadult, and this is RMS leg. So you can clearly differentiate between a normal healthy animal and RMS affected shrimp. In some cases, the stomach also turns red. You can see the red stomach in color, and a little bit of yellow fecal matter. Not much white fecal matter in case of RMS. Little bit either white or yellow fecal matter floats on the water surface. So this is the white fecal matter. You can see here it's a yellow fecal matter. You can see the color of the shrimp also. It's entirely different when compared to the normal shrimp. In some cases of RMS, you find white muzzle. People thought that it is IMNV or mineral deficiency and started applying more minerals. You can see in the check tray the normal shrimp and RMS just before death. It's a weak shrimp, moribund shrimp. And in severe cases, they float on the water surface because of the gas bubble formed in the cephalothorax because of decomposition. And there is a huge mortality under aerator in case of running mortality. So this was a picture, got it from Thailand. And there is even there was a recent webinar from Indonesia. They told they also have running mortality syndrome. But the exact etiology is not known. But as far as the available information is concerned, 3 factors are there. One is Vibrio parahemolyticus, a particular strain that is producing a toxin called as T3SS1. So another Vibrio parahemolyticus that produces 2 toxins, PIR-A and PIR-B, is responsible for EMS in other countries. But in India, we have Vibrio parahemolyticus that is producing a toxin called as T3SS1, is responsible for running mortality. One more research shows that one of the students from Bharathidasan University, Mr. Anil Kumar, he has sent some samples for electron microscopy and some samples to RGCA also. So their research shows that rickettsia-like bacteria, the samples were sent to electron microscopy, one to Rajendra Nagar, Hyderabad Veterinary University, and another set of samples to a hospital, Vellore, CMC Vellore, for electron microscopy. Both the samples, it shows that rickettsia-like bacteria is also involved in RMS. So still the final results are yet to come. So at present, the available research shows that one is Vibrio parahemolyticus that produces T3SS1 toxin and rickettsia-like bacteria. And it was also mentioned in some other papers that the mineral levels in the hemolymph are also relatively less in Vanamy that affected with RMS. So we have to keep in mind, we have to manage Vibrio, and we have to maintain minerals also in the water to minimize RMS. And we don't know the impact of rickettsia-like bacteria on this. So, and finally, economics are important. The profit farmer gets is based on the survival he's getting at the end of the culture. Feed conversion ratio. So some cases, yesterday there was a report, feed conversion ratio is 1:4. So by applying 4 kgs of feed, farmer is able to harvest 1 kg. So naturally they get loss. So feed conversion ratio is important. Feed conversion ratio depends on the feed management. And treatments also, so they have to respond in time and treat certain diseases. So each and every treatment, they have to check cost-benefit ratio, how much they are spending, and finally, how much benefit they are getting out of it. For example, if they are applying a mineral in salt water, it's no use. If they are applying in fresh water, yes, it gives a bit of a benefit. So you have to applying preventive treatment. Prevention is better than preventive treatment. Not always go for treatment. So preventive treatment is not suggested. Prevention is better than preventive treatment. So that's all for now. Thank you very much. If you have any doubts, you can type in the chat box. I'll be able to answer. Thank you very much. Thank you, Marsco, for giving me this opportunity. Hope you have enjoyed it, and hope my voice is also clear to you so far. So thank you very much. If you have any doubts, you can type in the chat box. So if you have any doubts on any of the slides or any other doubts on stream farming, you are most welcome.
Sir, there is a doubt from Sai Krishna.
Yes, sir.
1 minute, sir.
Sir, can you please read out?
Yeah. Actually, so many people are typing, it has moved up.
Okay. Okay.
Can the shrimp be grown in pre-grown tanks till 10 grams?
Sir, it depends on the carrying capacity of each system. Normally, the carrying capacity in pre-growth is around 2 kg per ton of water. So beyond that, you have to go for additional support like nano bubbles or foam fractionator. But up to 2 kg biomass per square meter comfortably we can go. So beyond that, you may face some mortality.
What are all the winter feeding strategies to be followed during shrimp farming, sir?
Sorry, sir. What
are all the winter feeding strategies to be followed during shrimp farming?
Sir, every 1 degree drop in temperature, you have to reduce that feeding by 10%. Every 1 degree drop. In one particular winter, our water temperature was 19 degrees. That day, there is no feeding at all. So based on the temperature, you have to reduce your feeding.
Sir, one more interesting question, sir. Is shrimp culture viable in Jharkhand?
Sir, it depends on your water source, sir. For example, people are successfully able to culture in Punjab, Haryana, Rajasthan. Why not in your place? But you have to maintain the mineral balance. You have to check your water source. You should know your water mineral profile, and accordingly you have to make it up.
So this is question from Ali Dada. Vanamy growth is 5 grams per week. That means 20 grams in a month.
Sure.
Is it possible?
Yes, much more than that. Even 7 grams. Now Monodona is people are getting 7 grams, not one farmer, several farmers.
The treatments of WSSV is on only type 1. White spot are both type 2 and type 3. I also didn't get the query.
Sorry, it's not clear to me.
Yes, sir.
There is no treatment for white spot virus so far. That is clear. Only prevention. There is no treatment for white spot virus.
Sir, is it possible to biofloc shrimp farming, shrimp culture?
Yes. Very much possible. And so far we are successful in biofloc shrimp nursery and biofloc farming using seawater. There are several problems in low saline biofloc shrimp farming, but we are able to successfully culture biofloc near sea by using salt water.
Seeds traveling time 28 hours. How can manage? Is it possible?
Yes, it is possible because earlier we were sending from Nellore to Bombay, Bombay to Gujarat. It is taking almost 24 hours. Another 4 hours, it is practically possible. Even the brood stock they're sending by flight. It's taking almost 30 hours.
Sir, the query from Lakya Jyoti Das. Is it possible to culture white shrimp, Vanamy and tiger shrimp, Monodona together?
It is not suggested, sir, because I'll tell you one example. Maybe in 1970s, Monodon was imported to US for experimental purpose. After that, they had a particular disease. They were doing stylirostis, huge mortality in stylirostis. Because of mortality in stylirostis, they shifted to Vanamy. Vanamy, there was a particular disease called as runt deformity syndrome. It took 10 years for them that this particular virus, IHHNV, was transmitted from Monodon to Vanamy, and it is not affecting Monodon, but it is affecting Vanamy and stylirostis. So there is a high risk. Better to isolate. Yeah.
Sir, this is query from Ashish Dahiya. Can we use potassium chloride during molting period?
Sure, sir. You can use if your potassium levels are low. Normally, the recommended levels are 1 ppt salinity, 11 ppm of potassium in the water. So if it is below that, you can happily go for potassium chloride.
Sir, people are switching from Vanamy to black tiger.
Yeah.
Can you show on light on this, sir? Is it suggestible like that? He's asked.
Sir, it depends, sir. So far, it is successful. So a few people tried tiger, and they're able to get very good growth and very good profits they're able to get. But no, if everybody goes for bigger counts, like people are able to get profit because of they're able to go up to 20 count and 15 count. So if everybody produces 15 count, where is market for that? So earlier we were struggling to market around 1 lakh tons of Monodon, all counts together. Now all of a sudden we are able to produce 8 lakh tons per annum. So there may not be market for everybody.
So this is query from Ganta Hari Krishna. Sir, is there any interlinks among physical and chemical water parameters?
Definitely. For example, oxygen solubility, if the temperature increases, solubility decreases.
Sir, this is query from M. Ramesh. Impact of antibiotics on shrimp farming.
Impact of antibiotics on shrimp farming. So every year we are getting rejections. Still farmers are, some farmers are using, not all, some farmers are using antibiotics. It's getting detected after exporting.
Query from Parthasarthi Pradhan. What is the density without aeration?
Comfortably, you can go up to 20,000 if it is Monodon, 30,000 if it is Vanamy. Initial stocking.
Okay, sir. From Raju Ramaya. What is the salinity to be maintained in biofloc culture? Shrimp biofloc.
So we are successful about 20, sir.
Okay.
Others may be successful at low density, low salinity, but we are successfully, repeatedly, continuously able to produce at high salinities, about 20.
Sir, this is query from Soumitra Yadav. How to recover loose shell?
No chance, sir. Once if it return to loose shell, gone. It cannot eat feed, so we cannot treat it. So we can prevent the other shrimp turning to loose shell.
A query from Rupesh Deshmukh. How to treat pond after white spot disease if fully water cannot be drained?
It's very difficult, sir. People are using some other pesticides, but we don't recommend in a public platform because it's an international platform. So if you, it's very difficult. So you can personally contact me, but we don't recommend it.
Sir, query from Jakir Basha, sir. It is treatable yellow fecal disease?
Yellow fecal is almost similar to white fecal matter. Yellow in the sense it's the hepatopancreas contains carotenoids, some pigments. So initially when the shrimp is healthy, in the beginning of the white feces, it will be yellow in color. After some time, it will be white in color. So both are same. White feces and yellow feces are almost same. So these are nothing but sloughed off cells from the hepatopancreas. So since we know it's an anaerobic bacteria, keeping your pond bottom clean is the utmost thing, and maintaining, giving a very good feed. A very high protein feed also helps a lot.
Sir, query from Pratiksha. Which treatment we can use for seed adoption or before stocking of seed?
So there is no treatment, but there is a practice. We call it as acclimatization. We call it as thermal acclimatization first, and then chemical acclimatization, salinity acclimatization. In thermal acclimatization, we keep the bag unopened in the same water for half an hour so that both the temperatures becomes equal. Then we open the bag and slowly add pond water so that both the parameters matches. For example, if your pond water pH is 8.5, your transport water pH will be less than 7.5. So based on that, you have to gradually add water till both the parameters matches. So one indication that if you release a seed into the water, if it is happily going to the bottom of the tank, it indicates that your system is your acclimatization is proper.
Query from Shiva, sir. Treatment for dinoflagellates.
Dinoflagellates you can treat with the BKC and copper sulfate. So there are several chemicals available in the market, but they are not addressing the root cause. They are temporarily blocking the luminescence. So luminescence is because of an enzyme called as luciferase. All these chemicals, they stop luciferase action so that you won't find luminescence, but it won't kill dinoflagellate.
Sir, query from Ali Dada again. For Monodon hatchery, please shed light on steps after eye stalking till gravid female.
Once again, sir.
For Monodon hatchery, please shed light on steps after eye stalking till gravid females.
So, sir, there are two types of hatcheries. Some hatcheries, they procure gravids, that means fully developed, a brood stock with fully developed ovary. So straight away, it's already fertilized. In case of Monodon, if the ovary development is there, means it's already fertilized. Straight away, you can spawn that and use it for the nopplay production. Otherwise, if you want to maintain your maturation, you have to maintain both males and females in the same tank. In case of Vanamy, we, especially in Asian system, we maintain males and females separately. Once its ovary development is there in stage 4, we transfer that female to the male's tank for the mating. But in case of Monodon, you have to maintain both males and females in the same tank because there is a difference in maturation. In case of Vanamy, they mature the ovary development. After ovary development, they mate. In case of Monodon, they molt. Immediately after molting, mating takes place. So after mating, ovary develops. Once again, I'm repeating. In case of Monodon, they mate immediately after mating. Sorry, molting. First molting, mating, then ovary development. In case of Vanamy, ovary development, then mating. So by keeping this in practice, you have to maintain males and females in the same tank. And approximately we get around 4% of brood stock for spawning every day. In case of Vanamy, we get 12 to 15% also. But in case of Monodona, they may legs up to 1 million eggs per spawning also. In case of Vanamy, we get 1.5 to 3.5 lakhs.
Okay. Sir, how to recover loose shell in bore water Vanamy? Again, the same question they asked.
Yeah. It's very practically not possible to recover loose shell, sir.
Can it be cultured in steel tanks under normal water, as we cannot get brackish water at many places?
Sorry?
Can it cultured in steel tanks?
Steel tanks?
Yes, sir. With using normal water, as we cannot get brackish water at many places.
Sir, I never tried this, sir. I never tried. Several people tried this in biofloc tanks. I think I never come across a successful case.
Okay, sir. What is the possible cause when there is a massive mortality in pond at ethylene forming?
Sir, based on the mortality pattern, we can say that if it is a mass mortality, it is something related to environment. Maybe DO gone down, high ammonia, high temperature. In case of disease, the mortality is gradual. All of sudden mortality means it's 99% of the cases. It is related to water quality until and unless there is poisoning. Every year we'll get 1 or 2 poisoning cases. Other than that, in case of, if it is there, mass mortality means related to water quality only.
Sir, is there any line of treatment for RMS disease?
See, I told you exact etiology is not known. So available research shows that, pointing to 3 factors. One is Vibrio parahemolyticus that produces TS331 toxin. So you have to focus on Vibrio control. The second one is rickettsia-like bacteria, but we don't know the treatment for rickettsia-like bacteria. Even diagnosis is not available to prevent it. And third one is mineral imbalance. So this first and third we can focus on Vibrio control and focus on mineral imbalance. So we can minimize RMS, but so far we are not able to completely control RMS.
Sir, what price will make profit to shrimp cultivators?
At what price? At what price?
Yes, sir.
Sir, it depends. It varies from area to area also. So if you go to West Bengal and Gujarat, seed price is 60. In Andhra Pradesh, it is 30-35 paise. So we get at a half rate. So our survival rates are better. Our power tariff is less. Your feed rate. So feed rate also varies from area to area. Andhra, it is cheaper when compared to other states. All inputs like seed, feed, power, everything is relatively less when compared to other states.
Now transportation takes a major part about costing, sir.
Even for the raw material price also, Andhra people get 20-30 rupees extra when compared to other states.
Yes, sir. Sir, this query from Tadisetti Kanakadurga Prasad. How to remove of bacteria that was helpful to treat ammonia in RAS culture, RAS culture?
Why you want to remove useful bacteria from RAS? RAS, that biofilter, there should be Nitrobacter and Nitrosomonas should be there. We purposefully maintain that particular bacteria to remove ammonia and nitrate. I am not clear with that question.
Yes, sir. Yes, sir. I think we covered all. What is the stocking density of Vanamy in 8 diameter capacity in 50,000 liters of water capacity?
So forget about number of Vanamy, sir. That depends on the carrying capacity. For example, I told you can comfortably go from 2 to 5 kg per ton of water depending upon your infrastructure. For example, your tank is 50 tons. You can go up to 100 to 500 kg. Sorry, 100 to 300 kg. So in order to get 300 kg, how much number you have to stock? For example, your target is 10 grams. You can stock more. If your target is 30 grams, you can reduce by 3 times. So
Sir,
it depends upon your target count and depends upon your carrying capacity of your system.
sir, can we grow Vanamy in fresh water?
So in brackish water, comfortably you can go up to 3 kg per metric ton of water.
Okay. What is the minimum
Somebody has asked
salinity
about
required to grow
zooplankton
Vanamy, sir?
fermentation. Okay, please.
How to control green water in bore water Vanamy culture? I think these are all farmer problems are coming, sir.
Mahinder, can you hear me?
Yes. Yes, sir. I am able to hear you, sir.
Yeah.
Sir, I think we have covered almost all questions which have given by participants.
Okay.
Thank you, sir.
Hope everybody enjoyed this. Thank you
Yes,
very
sir.
much for your patience hearing, and thank you, Mahinder, for the opportunity. Thank you very much.
Shushri,
Yes, sir.
yeah,
Sir,
please
thank
tell the
you.
vote of thanks to all.
Yeah. On behalf of Marsco Clinic, Aqua Center, I would like to thank everyone. I would like to thank Dr. Ravi Kumar, sir. You have covered the session beautifully. And also you have covered that how to culture the stream with like prevention is better than cure way. So you also discussed how to select the seed as well as how to maintain the seed quality in a very simple method. We have got like understood, and I think our participants have understood like how to like select the seeds in a very simple method. You can do in your like when you are going to the hatchery, you can do in there. And also, I would like to thank sir. You explained in the research way as well as in the farmer way how the farmer captures the problem and they will solve in that way. And also the research scholars can how to do the research as well as the students also. And you also able to that is the difference how to like identify the white spot virus as well as the white fecal syndrome. And I suggested how to maintain the proper GMP. That is also very important in shrimp culture. And you also discussed the and how to cover the running mortality symptoms. How to know the what are the symptoms you have to identify the running mortality. I would like to thank on behalf of Master Clinic, thank you sir for giving us the valuable time.
Welcome, madam.
Yes, thank you, sir. I would like to thank our speakers, Dr. B.K. Mahapatra sir and Dr. Ravi Kumar sir for covering beautifully the session. And I would like to thank all the participants all over the from India as well as joined from out of India. Thanks to you everyone. Please stay tuned to Aquatic Insects Aqua Center. We will update the next webinar session. Thank you everyone. Thank you sir.
Thank you, sir.